So we will continue today from where we stopped in last lecture. In last lecture, we calculated the time the chemistry book took to reach the ground. Today, we're going to continue and find the time the biology book takes to reach the ground, to hit the ground. So let me refresh your memory here. We had Jeremy, Jeremy throws his bio textbook upward from his window with a speed of 2 meters per second. Vanessa throws her chemistry textbook downward with an initial speed of 2 meters per second from the same window. So one of them is up, the second one is down. The height from where they both started as 12 meters. So I will redraw the here for the bio book. So if this is my ground, if that's the ground, and this is the window here, this is my reference point. The initial velocity is pointing up. I have the acceleration pointing down. So this is my 0 meter where I have y naught. And I took my positive reference to be pointing downward this way, which means the displacement here is at a distance of 12 meter. So in this case, look, we have the equation as y equals to y naught plus v naught t plus half a t squared. In this case, I have y as 12, y naught as 0, the velocity as -2, because it's pointing up against my positive reference, times t, half acceleration is positive, t squared. Rearranging this equation, we will get a quadratic equation -12 equals to 0. So if I am to solve for t in this case, then I have t equals to minus b, which means that this is going to be positive plus minus square root of b squared, which is -2 squared, minus 4 times a, 4.9 times -12 divided by 2 times 4.9. So in this case, I have t equals to 2 plus minus. This one is 4 plus 235.2 divided by 9.8. And in this case, I have t equals to 2 plus minus plus 4 square root as 15.46 divided by 9.8. In this case, I will notice that I have a negative number, which is 1.37, that is a trivial number, and a positive number that is 1.77 second. So the time the biology book took to reach the ground was, yes, go ahead.
Just to clarify, is this the same question we did last class?
Yes, this is the second part of question A in that example. So this is for the biology book. We did the chemistry book, and we found that the time the chemistry book took was 1.37 seconds. Now we need the difference. How long the bio book is going to take more than the chemistry book, which is here T difference equals to T bio minus T chem. In this case, T difference is 0.41 seconds. Which book has a greater speed when it hits? What do you think?
I would assume the biology one because it was in the air for longer.
Okay. By the way, assuming zero air resistance, right? So
if we assume that it's just acceleration acting on it, would they not be the same speed?
they will be the same speed, and we will see why. Because v squared equals to v naught squared plus 2ay minus y naught. So if I calculate the bio, then the initial for the bio is minus 2 squared plus 2 times 9.8. Remember, the acceleration is the same positive reference times 12. If I do the same for the chem, see, so because of that squared, the initial velocity was squared, the distance, as long as they have the same magnitude, the direction did not matter being down or up, because what's going to happen, the bio book is going to reach the maximum height, and then will go down. In this case, right at the point where he started, it would come back with the same velocity. However, it's in the opposite direction. So here we found that v bio squared equals to v chem squared equals to
15.466.
15.466.
And sir, it would be okay for us to use VI instead of VO because I just find VI a lot more easy to read.
Use whatever you want, whatever you find, convenient to you, use it.
Okay, thank you.
Okay. So if you are to write it as the vector, so that's the velocity, 15 0.46 meter per second.
I have a question.
Yeah, go ahead.
How did you get the 239.2, I think it was?
This one?
Yeah.
4 plus this.
Oh, okay. Thank you.
You're welcome. Okay, so this is the end of the material for quiz number 1. This is what we have covered now, the material for quiz number 1, and now we're going to move to introducing and refreshing your memory of vectors. So vectors, as we have seen, are different than scalars because they not only have magnitude, they also have directions. So we'll talk about the notations, we'll talk about multiplication and division involving scalars, and we'll also talk about the addition and subtraction using components. So you should refresh your memory by going to those two sections while we are covering also 3.1 and 3.4. If you're interested in reading for next lecture, then read about the two-dimensional motion, which basically same constant acceleration. So the notation, vectors have either an arrow at the top or in bold variables. Both of those are, used to indicate that those variables or those quantities are vectors. So either bold or with the arrow. Vectors, they have their magnitude as positive, and the way we write the magnitude is either this way or that way with no vectors. Same thing for velocity, same thing for accelerations. All those are vectors. Now, if I am to divide the vector by a positive scalar, in this case, only the magnitude will be affected. The direction will be the same. If I am to divide my vector with a negative scalar, then in this case, the magnitude will be affected and also the direction, because the negative here means that the direction is 180 degrees shifted, which means in the opposite direction. Now, if you multiply this vector by a positive scalar, then only the magnitude will change. If you multiply this vector by a negative scalar, the magnitude and the direction. So the negative sign here would reflect on the direction of the vector. So I can write a negative vector as a positive, however, pointing in the opposite direction. So let's look at those two vectors, A and B. If I want to add them, how do I add two vectors? What I usually do is I bring the second vector and draw it from the head of the first one. So I put the tail here, and then I go this way. Then in this case, starting from the tail, ending at the head of the second one, I get my vector that represents the summation or the addition of the A and B. If I start with B, I will be getting the same answer. So A plus B is no different than B plus A. So if I'm starting with B, I would draw the A vector such that the tail is at the head, and then I would connect the tail of the first one with the head of the last one, or the second one in this case. So let me now ask you, if I have those three vectors, B, Q, and R, those are bold, which basically represent vectors. Which one of those figures represent the correct answer to P plus Q plus R? Is it A, B, C, D, or E? And why?
C, I think.
Okay.
I say B.
C, B,
B.
B.
I think it's B because it has to be like the vectors have to be aligned from tail to tip, and so you take the vector that you draw for like the summation of all of the three of them would have to be from the beginning to like the end vector
Okay.
that we're looking at, which is P and R.
Okay.
So I think it would have to go from
So let me ask you this. Okay, so what you said is okay. So let me ask you why A is wrong.
The direction of
He's going in the wrong
is
direction.
flipped.
The direction of
Q.
the direction of the Q. So Q, so what's this vector based on your understanding? If this is a Q, then what shall I call this? Huh?
Negative Q.
negative.
Negative Q. You are absolutely correct. And that's the reason why A is wrong. And also C is wrong because I have negative P, and D is wrong because I have negative R. So the correct answer is B. Now, what about subtracting? Which one represents the correct answer to P minus Q?
D.
You said B.
D.
Somebody said D.
I think it's D as well.
I think it's D2.
D.
Yeah, D.
I think it's D.
D.
Yeah, I
D.
think it's
D. 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 So most of you are saying D, and I agree with you. Why D? Because when I say P minus Q, this indeed means that I am adding P to a vector that I'm calling minus Q. So it's easier for me to flip the vector and add it. So here I'm adding a Q to P, which is wrong. Here I'm adding Q to minus P, which is wrong. Here I'm adding minus Q to minus P, which is wrong. So the only correct answer is P and minus Q. Again, mine are not bold, that's why I put the vectors right on the top. So the correct answer is D. Now let's look at the vector components here and the definition of the projection. Remember we said that any vector is defined by a magnitude and a direction. For me, if this is my coordinates and I am drawing a vector where the tail is right at the origin, and this is my vector. Then based on what I have just said about the vectors, I need to define an angle. So the magnitude only, but the magnitude by itself is not enough. I need also to define the direction, which is basically the angle here. Is going to take care of this. Now, if I am to reference this angle in terms of north, east, west, south orientation, then how can I describe this theta? Remember, I have to be using one of the axes as my reference, right? Because at the end, an angle here is defined between a vector and one of those axes. So if X, yeah, go ahead.
To answer it,
Yeah, go ahead.
I think it should be east, north, and then the degree of theta.
North of east, right?
Yes, that's how you say it.
That's how you say it. So the east here is your reference axis, and then you go toward the north. So I can say that theta here, I can describe it as this theta north of east. So this one is my reference axis, and then I'm going north, which basically defining that I am the angle between this vector and my x-axis. Okay, so if I am now to find the projection of that vector, I want to correlate this vector to my coordinates. How do I correlate this vector to my coordinates? I usually project those vectors on my coordinates such that each vector has two components. One of them on the x-axis and the second one on the y-axis. So in this case, if I am to project this vector that has its tail right at the origin, then I would be drawing a line such that this line is perpendicular on the axis. Now, when I do this, I get a component right on the x-axis that I am calling the projection of the vector on the x-axis, which means this is the value of the A on the X, and that's why I'm calling it AX. Now, using the trigonometry, I can say that this can be defined by the cosine expression, which is cosine theta equals to the adjacent divided by the hypotenuse, right? Which is A in this case. Or I can say now that this component, which is the projection on the x-axis, is indeed A cosine theta. And keep in mind that this is positive as long as this AX component is pointing in the positive direction of X. Now, I'm going to get something similar when I project this vector right on the y-axis. In this case, I will get the AY component, right? So if this is theta, then this is the complement. This is 90 minus theta. And using the same expression, I can say that cosine 90 minus theta is indeed the adjacent, which is AY divided by the hypotenuse, right? Which is A. Now, cosine 90 minus theta is indeed sine theta. And this equals to AY over A. Or I can say that AY, the projection of the vector on the y-axis, is indeed A sine theta. So this is how I get the projection of a vector right on the coordinates. Now, always keep in mind, as long as you have the A here projected on the axis and the theta is in between, then it is A cosine. If it's the other angle that has the complement, it will be A sine theta. Or cosine 90 minus theta, which is sine theta. So this is how we do it. Now, I got the projections, and those two components can describe my vector fully. Why? Because if I got those projections from the magnitude, knowing the magnitude and knowing the angle, I can now go the other way around and find the magnitude and find the angle from those projections. How? Let's see how. If I want to get A, then A, using the Pythagoras, is AX squared plus AY squared. So I got the magnitude. If I want to get theta, which basically is going to give me the direction of the vector, then it is tan inverse AY over AX. So knowing the angle, knowing the magnitude, I can get the projections. If I know the projections, I can go back and find the magnitude and the theta, which basically means the angle. Any questions so far?
Yeah, sir. Are these equations like preset and we can just use them over and over again, or do we have to be like different cases for each question?
You have to be careful that this length is a sine, and this one is a cosine theta. Just it's up to you it's up to you how you wanna know it. But again, you don't need to memorize, but you need to understand, because this is one of the issues that students get, confused somehow if they don't understand it well, and they keep mixing between sine and cosine. So this is one of the common mistakes, I would say. So
Okay,
be careful on operating on those expressions, those equations. Be careful when to use cosine, when to use sine. If you understand it, then you will never make that mistake.
Okay, thanks. And just to clarify, since I know when to use sine and cosine, sine theta is you only wrote sine theta because the cos of 90, the remaining angle basically will always be the sine function, right? Okay, thank you.
Cosine that angle, if you apply the same concept for AY, it is cosine this angle, but cosine 90 minus theta is sine theta.
Okay, thank you so much.
You're welcome. Okay, so let's do this example now. Here in this example, we have the following. We have two vectors, vector A and vector B, where vector A is 5, has a magnitude of 5 meters and an angle of north of east, while B is a 3 meter with an angle of west of south. So this is how we should be doing it. So if I am to calculate those components, then I will draw those vectors here. So this is A, and this is 51 degrees, and this one is B, 71 degrees. So in order to here, what do we need to do? For the vectors shown below, determine the x and y components using the given coordinates. So what do we need to find? We need to find AX, AY, BX, BY. So what is AX? Again, AX, don't forget that this is perpendicular. This is AX. This is AY. This is BX. This is BY. Now, notice that BX and BY should be negative. right? Because they are pointing in the opposite direction. We're gonna come to this, but let me first put the expression for AX. So based on what we've done, AX is A cosine 51. Then definitely AY should be A sine 51. So if you understand how to do one of them, the second one should be the sine, right? You won't be doing a mistake. What about BX? BX is negative, so I'll put that, I don't need to forget the negative. Then this is B, and then it is sine 71. BY is negative B, but cosine 71. So yes, go ahead.
This is a dumb question, but how are you supposed to know whether you're going to be using sine or cosine?
Okay, I'll tell you how I do it. If I am to find the component, the projection that has an angle here in between. So take A and take AX. It's always the cosine, the angle that is in between them.
So that's just given, like we have to remember that every time.
Just keep this in mind. You want AX, right? Then F1 is between the vector and AX, then you take cosine. You want AY, but the 51 degrees is not in between, so you take the sine. This is how I do it.
So that's how you do it so quickly.
Yeah.
Because we did this last year for vectors, like we had calculus and vectors combined, and we had to actually like go through it, like draw the triangle, and like it would take longer. So I was just wondering how you did it so fast.
Yeah, that's how I do it. I look at the projection and I see the angle between my vector and the projection. I take a cosine.
Okay.
If the I do AY, but the angle is not between AY and A, then I take the sine.
Okay. And that works every time.
Of course.
All right, perfect. Thank you.
You're welcome. Okay, so AX here we said is 5 cosine 51. AY is 5 sine 51. BX as minus 3 sine 71. B1 is minus 3 cosine 71. Yes, go ahead.
What you just explained, is that in the textbook?
Say that again.
What you just explained, is that in the textbook?
It should be.
Okay, thank you.
Which one? You mean the rule of the cosine sine?
Yes.
This is something that you develop from working in that field. So always look at it this way. The vector that you are projecting on the axis, if you have the angle between that vector and this axis, then this projection is this A, the magnitude of that vector, cosine. And this applies on AX.
Okay, thank you.
You're welcome. Cosine 71 times 3, which is minus 0.98 meters. Okay. We are going to use those ones later on, but those are the projections of those two vectors. Now let's move on to this example. Which of the following correctly illustrates the x and y components of vector A for the given coordinate system? Which one do you think is the correct answer? Be careful when you look at the coordinates. Hint, this coordinate has x pointing up, y pointing to the right. So they are not the same as the coordinates we saw earlier. Which one represents the correct answer?
D.
You said
E.
D.
you said D.
I said B.
You
B.
said D. B.
I don't see any.
I think it's C.
Uh-huh. So we have B.
D.
C.
I'm gonna
go with C.
Say
Is-
E.
Is it E?
It has, I think, E.
Oh, E.
I'm guessing E.
I think B.
B.
C.
D.
C.
A.
D.
D.
I think none of them.
No, there's no none of that. You just invented an answer. Anyway. Okay. So why it is not A?
Because AY and AX are in the wrong place and they're pointing in the wrong direction.
Okay, that's a good start. What about B?
The AY and the AX are on the wrong sides.
AY and AX are on the wrong side. Okay, I agree with you. What about C?
AX is pointing in the wrong way.
Okay, so let's
Directions
agree on something here. The component that is vertical should be
X.
X, and the component that is horizontal should be
Y.
Y. Excellent. Which means this is wrong and this is wrong. Now, why E is correct?
It's
E
the
is-
only one.
Yeah, E is correct because if you bring this vector to the coordinate, or bring the coordinate actually to the vector and put it right there. If you project this vector right on the X, this one should be the X, right? So if this is A, then this one should be AX. And this one should be AY. So AX is pointing up, AY is pointing to the left. And don't forget that the projections for a vector is indeed the component that if you add them, it should give you the vector.
Wait, sir, I'm confused.
Why?
Used to.
Why?
Isn't the AY, wouldn't that be the vertical component and the AX would be the horizontal component?
Does this coordinate says that? Look at the coordinates. The coordinates are not, they're changing. They could be different
Okay, I get it. I see.
from a problem to another. It depends on how you orient them. Always
Yeah,
remember
no.
that the reference is basically how it was even given to you or how you decided to be. And here in this problem,
Orientation.
the orientation of the coordinates, y is horizontal pointing to the right and x is the vertical. So you can think about it as rotated. They're either rotated or you're looking at them from a different angle.
Okay, I see it now. Thank you.
You're welcome. So that's why if you look at those two components, the one that we calculated here, you will see that AX is pointing up, which is this guy pointing up, and AY is pointing to the left, which is basically what's happening here. And that's why E is the correct answer. Let's move on. Well, the time here is very tight. Okay, so if I have several vectors that I would like to add mathematically, then in this case, what do? I find their projections on the x and y's, and I add their x's, I add their y's, and then I end up with a total x value, total y value. Then this is the projection of the summation of or of the total vector that represents the addition of those three vectors. And then how do I find the magnitude? Simple. I can use Pythagoras here, dx squared plus dy squared, and theta tan inverse, exactly what we have seen earlier, for the x. So once I know the two components of a vector, it's the x and the y, I can construct the vector. Now, same thing if I have some, subtraction as well. So a mix of vectors, adding, subtracting. At the end, you find the projections, then you add, subtract those projections, you get the total value on the x-axis. Same thing for the y, based on the sign here. So here you're subtracting B and C from A. So you can see that BX is negative, CX is negative, BY is negative, CY is negative, because the vectors here have been subtracted. And then you find the total X component, the total Y component, and then you can construct the vector, the total vector again, finding the magnitude and finding the angle theta. But be careful when you find the angle theta, be careful on how to describe its reference to the coordinates. The same thing we talked about earlier, which is north of east or west of south, and so on. Now here in this example number 2 is referring to example number 1, saying, well, find the vector sum R that is the summation of A and B. So what do? We said we will show you what do we do here. If I go back to that question that I did calculate those values, and I got those values, then I can say now that Rx is indeed AX plus BX, and this equals to 3.14 plus or minus 2.84, and RY, which is AY plus BY, which is 388 minus 0.998, right? Then find Rx, find Ry, then you can find now R. I'm going to leave the numbers for you. This is the magnitude, and then you can find theta, which is the tan inverse ry over rx. Okay. Now something to pay attention to, let me show you here. If you want to add those two vectors, so draw a parallel to A, right? And then if you draw a parallel to B, the intercept point here defines the vector that you need to get. So in this case, be careful that this R, those components, the projections that you found are those ones. Those are Rx, and this one is Ry. Then the angle you found is this one. And this one, based on the northeast, is called what? North of east. So this one is going to be north of east. Okay? As simple as this. Now let's do this example here. We're going to come to your questions, but let me finish first the material I have here, and then I will be available to answer any question that you want. In this example here, I have A plus B plus C equals to 0, those three vectors. And vectors A and B are given. What is C? C, indeed, is minus A, if you think about it, plus minus B. Is that right? So if you want to draw the summation of minus A and minus B, I would first draw minus B, then minus A, and then add them. So if you add them, if I have this one minus B, and then this is minus A, so guess which one is the answer?
E.
What about B?
B.
Make sense? Didn't we say that the total vector starts from the tail of the first one and ends at the tip of the second one? So this one is, let's see. Okay. Now let's do this last example here. This example is similar to what we have done, but let's just formulate the problem here. So we have a car that's traveling at 15 meters per second. So V1 is 15 meters per second, and this is 16 degrees north of east. And V2 is 22 meters per second, and this is 21 degrees west of north, right? So if I am to draw this, it will be V1 15, 16 north of east. So this is V1, and this is 16. The angle is a bit. And then this one is 22, 21 west of north. West of north is going to be here. So this one is 21 degrees. So this is V1, this is V2. So what do I need to find? I need to find V2 minus V1. So in this case, what do? I find V1x. Can somebody tell me what's V1x?
the cosine of 16 times 15.
Cosine 16. What is V2x? V1y, sorry.
Same thing, but sine.
Excellent. 16 degrees. What is V2x? What is V2y?
Hopefully cos.
It is cos, but is it positive or negative? Look at it.
Positive. B.
Positive.
The x value is negative.
Is positive and the x value is negative. You're absolutely correct. So that's it. You found the x components, you find the y components, and then what do?
Add them together and then get the root of both.
It's not adding, it's subtracting. It's V2 because we're looking at V2 minus V1, right? So you have to be careful. So let's calculate what is V1x. Cosine 16 times 15, 14.4. What is V1y? Sine 16 times 15, 4.13. What is V2x? Sine 21 times minus 22.
Negative 7.88.
Thank you. What is V2y?
$20.5.
20.5. So I want you to give me those numbers. So now I would, let me call this is V tot x, which is V2x minus V1x. What is V2x? Minus 7.88 minus, what is V1x? 14.4. Am I right?
Yeah.
Okay. And the answer is
Negative 22.28.
V tot y, which is V2y minus V1y. What is V2y? 20.5. What is V1y? 4.13. So V tot y is
16.37.
16.37. So I got the x tot, I got the y tot. Now I can find V tot, which is minus 22.28 squared plus 16.37 squared, and the answer is what's the answer?
27.6.
27.6. What about the tan inverse? 16.37 divided by minus 22.28.
Negative 36.31.
Where's this angle? So let's go back to here. This angle V2 minus V1. So let me draw this again. So this is V1. I am calculating V2 minus V1. So I would be interested to find minus V1. So this is minus V1. Where is V2? This is V2. So where is the angle? So the angle here, based on my calculation, is, and I have the y being positive and the x being negative. So this is the angle. Make sense?
Wait, sir. So the angle of negative 36 degrees, we'll put it in the second quadrant? Because if it's 36 degrees, shouldn't it still be in the first quadrant?
Hold on a second. So this one is V tot y. Be careful to my projections, right? Those are my projections, right? This is V tot x. Is that right? So this is my, I'll put them in different color. So this is my V tot x. And this is my V tot y.
That makes sense. Yeah.
If the y is negative and the x is positive, y is negative, x is positive, then the angle should be in the fourth quadrant. But because the y is positive and the x is negative, then whatever angle you get here, you have to add to it 180 degrees.
Okay, that makes more sense.
Okay, so this y, because regular calculators, they don't distinguish between which one is negative. I have two cases where where this ratio can be negative. If x is negative, y is positive, then this ratio is negative. If x is positive, y is negative, then this ratio is negative. Newer calculators, they do distinguish now between which one is negative, which one is positive. But older calculators, they don't distinguish. So you have to be careful when you calculate the theta. If the signs of your components are y positive, which is in this case, this is y, right? This is the V tot y, right? This is the V tot y. If the y component is positive and the x component V tot x is negative, then you are in the second quadrant, not the fourth one.
So you just look at the totals of x and y to determine
You look at the sign of your projections.
Oh, okay. All right. Thank you.
So here, if you plug in those numbers and click on execute, you're gonna get minus 36 degrees, but that's wrong. The actual angle, you should add 180 degrees to it to give you the correct angle in the second quadrant. So here the angle would be plus 180 degrees, and the angle is, of course, from the x, the angle from here. The angle from here is 143.7 degrees. Okay, which means that this angle is what?
The 36.
This is the 36 degrees. Make sense? Okay, so let's stop here